everyone, today we're going to talk about setting up ratios and proportions and determining their proportionality by forming and simplifying fractions. What is a ratio? A ratio is a comparison of two quantities or more. For example, if you have a recipe, for every 2 eggs, you need 3 cups of flour. That would be an example of a ratio. You're comparing eggs to flour. If we look at this slide, it says using your colored blocks, create a fraction equivalent to 2/3. So if we look here, we see that we have 2 purple blocks over 3 blue blocks. If I look on the other side, I have 4 purple blocks and 6 blue blocks. It says, how do you know your fractions are equivalent? Well, if I look at this fraction, I have 2 over 3. And if I look at this fraction, I have 4 over 6. I can reduce 4 over 6 by dividing each of the numerator and the denominator by 2, and I get 2/3. Therefore, since my fractions simplify to be exactly the same, I know that my fractions are equivalent. If I'm looking at these ratios, and if I look at the second example, I can use the blocks to help me figure out that for every 2 purple blocks, there are 3 blue blocks. Therefore, when I add another set of 2 purple blocks, I have to add 3 more blue blocks. Do you think there is more than one way to write a ratio? If so, what are some of the different ways? There are actually 3 different ways to write a ratio. So when writing a ratio, take the 2 numbers that you are comparing and put them together in the order they are given to you. That's very important to remember. So if you're comparing cats to dogs, cats must come first. If you're comparing dogs to cats, dogs must come first. There are 3 ways to do this. You may use a fraction, and if we look, there's some examples down here. A colon, and that would be an example right here with the 2 dots, or the word to. So those are the 3 different ways to write a ratio. One important thing to remember is that you must always simplify your answer. A ratio is always written in simplest form. If we look at this example, we're given graphing calculators, protractors, and compasses. So now we're going to fill in the blanks. There are blank graphing calculators to protractors. Well, if I look at the graphing calculators, I see that there are 5 graphing calculators. These would be the protractors right here. And I see that there are 7 protractors. Now I'm comparing blank protractors to blank graphing calculators. So now there are 7 protractors to 5 graphing calculators. These tools over here are compasses. They help you draw circles. So in this problem, we're comparing blank compasses to blank protractors. Well, there are 4 compasses and there are 7 protractors. There are 5 graphing calculators to 4 compasses. There are 7 protractors to, now it's talking about total objects. So now we're going to add everything together, which would give us a total of 16 objects. So the number of graphing calculators is 5/16 of the total number of objects. Why can't a ratio be expressed as a mixed number? So a mixed number would be something like this, 2 1/2. So remember what we said in the beginning. A ratio compares 2 quantities. A mixed number does not. And if we look at this little box on the bottom, it says a ratio is a comparison of 2 things. An improper fraction compares the whole to the part, while a mixed number does not. So if we look at this example up here, right, we're not comparing anything to another number. That's just the number 2.5. However, if we convert it to an improper fraction and we have 5/2, now we're comparing one thing to another, the numerator to the denominator or the whole to the part. How can you determine if 6/4 and 8/12 are proportional? So there are actually two ways that you can do this. So method 1, which is given to you right here, is simplifying the fractions. So 6/4, we can divide the numerator and the denominator by 2, and it would be simplified to 3/2. If we look at 8/12, 4 is the greatest number that goes into both of those, and that simplifies to 2/3. Therefore, the ratios are not equivalent, so they do not form a proportion. If we look at method 2, it talks about cross products. So what that means, if I rewrite the two fractions, we're trying to figure out if these two are proportional to each other. So I'm going to cross multiply. 8 times 4 is 32. 12 times 6 is 72, and since these two numbers are not the same, the cross products are not the same, the ratios are not equal, or they are not proportional to each other.